Hey everybody, it's Mr. Morse. We're going to talk a little bit about physical and chemical changes or reactions today. Just a quick note that RXN period is an abbreviation for reaction. You're going to be writing that word a lot this year, so let's go ahead and just start using that in your notes. RXN, great abbreviation for reaction. So talking about physical and chemical changes, we first need to talk about the three states or phases of matter. You've probably heard about these before. We have solids, liquids, and gases. Start with the solid. Molecules make up a solid are arranged in regular repeating patterns. They're held firmly in place but can vibrate within a very limited area. And they keep their shape. They don't change shape when they get poured from one container to another. As we increase in energy, we start to vibrate molecules just a little bit more and we get liquids. Molecules that make up a liquid flow easily around one another. They're kept from flying apart by attractive forces between the molecules of the liquid, and they assume the shape of their container. If I pour from one container to the next, we change shape, but the molecules stay together in that liquid form. And as we add more and more energy, we eventually get a gas. Molecules that make up a gas fly in all directions at great speeds. They are so far apart that the attractive forces between them are insignificant. They don't come together. They take up their entire container. So if I open up the container and now the room is my container, they're going to fill up the entire room. So as we add energy, we go from solids to liquids to gases. Just another picture of this. Again, solids hold their shape. They have a fixed volume. Liquids take the shape of the container, free surface, and fixed volume. And gases take the shape of their container and the volume of their container as well. And again, as we go from solids to liquids to gases, we increase energy. And just one more picture. We took a piece of ice, which is solid water, and we started to heat it up. We increased the energy. We turned it into liquid water. And eventually that liquid water boiled or evaporated and turned into gas. You can see the pictures there. The solid ice, the particles are very close together in a very fixed pattern. The liquid water, there's a lot of particles there, but they're kind of randomly mixed, but still close. And in the gas, there's only a couple of them there because they take up a lot of space. So we need to know a little bit about the states or phases of matter, because as we increase or decrease energy, that actually gives us different things. Well, if we have liquid water and we decrease the energy, we all of a sudden get solid water, which are chunks of ice. Or if we have liquid water and we increase the energy and we start to boil it, eventually all that liquid disappears. It boils into a gas that takes up the entire room and we don't see it anymore, even though it's technically still there. So now chemical changes or reactions. There's 6 signs of a chemical reaction, and you'll definitely want to write these down and probably leave just a little bit of space after each one in your notes because we'll talk about these a little bit more in class. So number 1, you have an unexpected change in color. And that's very important. It's unexpected. It's not like you mix yellow and blue and you get green. You've known that for a long time since you've done that with watercolors in elementary school. But maybe we have 2 clear liquids. We mix them and all of a sudden we get pink. That was unexpected. That's a great sign that a chemical reaction or a chemical change has happened. The next sign of a chemical change or reaction is an unexpected change in temperature. Again, if I mix really hot water with kind of room temperature water, I would expect that water at the end to be warmer than the room temperature water started out at. But if all of a sudden I mix 2 things together and it gets really hot or really cold unexpectedly, that's a great sign of a chemical reaction. Instant hot packs and instant cold packs are a great example of that. You click a little button, you mix some things together, and all of a sudden we either get really hot or really cold because a chemical reaction happened. The next sign, we produce a gas. We start to see bubbles. So no gas was present to begin with. There was no bubbles before the reaction, but we mixed 2 liquids or a solid and a liquid, and all of a sudden we see bubbles, and we're producing a gas. Great sign that a chemical reaction has occurred. The next one, we make a solid, or the fancy science word for that is a precipitate. So again, we mix 2 liquids together. There was no solid to be found to begin with, and all of a sudden a solid forms. Sometimes chemicals will come together in new ways when I start to mix them, and they would rather come together as a solid than be a liquid. All of a sudden we've made a new substance, and we see it as the solid form called a precipitate. These last 2 are a little less obvious and don't happen as often, but we could have an unexpected new odor. Again, maybe we mix 2 things together and we expect them to have a certain smell, and they do. Maybe not a chemical reaction. But all of a sudden we have no noticeable smell, the reaction happens and it smells really bad. Could be a sign that a chemical reaction has happened. And last, we make a sound, we get a pop or a boom. Energy is given off as the reaction happens, a great sign that there was too much energy to begin with. So as the new things combine, the chemicals combine into a new substance, we hear that sound as a pop or a boom. So chemical reactions are changes. They take place on the molecular level. We're talking about atoms and molecules unhooking and recombining in new ways. A chemical change produces a new substance. We have the same atoms we started with, but they're rearranged and hooked together in a different way, creating a new chemical substance. And you can't get back what you started with. Unless we could get really, really small and go to the atomic level and rip those molecules apart and reorder them, we're stuck with what we end up with. So if we make something new that wasn't there before, we can't go back to what we started with. We probably had a chemical reaction or a chemical change. So some examples of chemical changes might be combustion or burning of a candle. Cooking an egg. When we crack that egg and put it in that hot pan, we get something different at the end than we had at the beginning. We have a hard yellow yolk that softens up as we cook. We also had all that gooey stuff around the yolk that gets white as we cook. We get the egg white. And that's actually a chemical reaction among the proteins inside of the egg that we can't get back that gooey yolk to begin with. Or rusting of an iron pan or an iron nail. Anytime we have rusting, iron is actually mixing with oxygen in the air in a chemical reaction that we can't get back. We scrape off the rust, we're actually scraping off the entire new thing that we just made. So now the other one, physical reactions or changes. Physical changes are concerned with energy and states of matter. A physical change does not produce something new. Changes in state or phase, like from solids to liquids to gases, called melting or freezing, vaporization or condensation, or another fancy one, sublimation. Those are all physical changes. If I take solid water, which is a chunk of ice, I heat it up and I get liquid water, I didn't make anything new. I still have the same water molecules hooked together in the same way. They just have a little bit more energy and a little bit more freedom of motion. But ice to liquid water, physical change, but it's still the same stuff. And then the last one, stuff gains or loses energy and order, and nothing new is produced. So maybe we gain energy and we become more disordered, like the molecules of a gas. Or maybe we lose energy and we become more ordered, like liquid water freezing into ice. But nothing new is produced. We have solid water, liquid water, water vapor, but those are all forms of water. No new molecules, no chemical reactions happen. Must be a physical reaction or a physical change. So some examples of physical changes, crushing a can. I crush an aluminum can. I still have the same stuff. It just looks different, but all the molecules are still in the same order. I didn't make any new substances. Melting an ice cube. We've talked about this one. I take solid water. I give it energy. We melt from a solid to a liquid, but I still have the same water, just with a little more energy, but nothing new was made. And the last one here, breaking a bottle. I take a glass bottle and I break it. I still have the same stuff. I didn't make a chemical reaction to make new pieces of the glass bottle or some new chemical substance. All the pieces are still there. If I tried really hard, took a little bit of time with some super glue, I could actually put that bottle back together. That's another just kind of on the side to think about with physical reactions. Here's what I have. Here's what it ended up with. If I took a lot of time and a lot of work and maybe some super glue, could I put it back together? Another example is cutting your hair. Obviously, you could take your piece of hair and glue it back in place. It would be nasty. You probably wouldn't want to do that, but it could happen. So cutting your hair would be a physical reaction. You don't cut your hair and all of a sudden you get flowers. We don't make something new. It's a physical reaction or a physical change. So how to tell chemical and physical changes apart? A chemical change makes a substance that wasn't there before. There may be clues that a chemical reaction took place, one of those 6 signs that we just talked about of a chemical reaction. For physical reactions, the starting and ending materials of a physical change are the same, even though they may look different. So same stuff, looks different, nothing new is produced, must be a physical change or a physical reaction. So chemical and physical reactions, take a little bit of practice to kind of decide which one's which. The big thing again, chemical reaction, we recombine molecules and actually make a new substance that we can't put back to where we started from. Physical reaction, we're just changing the way it looks, giving it energy, making it more disordered, or making it more ordered. And we could, if we tried really hard, take all the pieces and put them back together and have what we started with.